Hello my dear students and welcome to Zenith Academy Online. My name is Shagufta Jaipuri and we are on part 2 of the chapter Electric Circuits for GCSE Physics A level students, that is year 11 students. And in this part of the chapter Electric Circuits, we'll be talking about current and charge, and we'll also talk about the different components of electric circuit. So let's get started. Now students, here what you can see, here there is a wire and a cable. Now what happens if you touch a wire or a cable which is not connected to any battery? Obviously you will not feel any electric shock since it is not connected. Okay. So now we know that if there is a conductor like wire, okay, there are no charges flowing right now. That is why we don't feel the current. Okay. We don't feel any electric shock. So suppose this is a cross section of a wire. Now in a wire there will be metal ions, we know, and there are free electrons. Okay, but they do not move on their own. There has to be some external force which makes them move. So he is Mr. Voltage and he applies the external force. Now here you can see voltage applying an external force, and hence the electron starts moving. So if you consider this as a cross section of a wire, okay, so this is a metal wires, that is why it is a conductor. Now here there are positive ions that do not move, they are stationary, and there are electrons. Now electrons keep on jumping and colliding with the wall and with each other, but they do not move in any particular direction until and unless a potential difference is applied across its ends. Now this potential difference is applied by Mr. Voltage. Now this potential difference or the force of Mr. Voltage is provided by battery. So when you attach a battery here and you close it, okay, so it means you switch it on. Now when you switch it on, here you can see this is the positive side and this is the negative side. So positive is here and negative is here. So what will happen? Electrons will start drifting towards positive side. Okay. So electrons will slowly start drifting this side. This is the direction of flow of electrons, but the direction of flow of current is opposite to the direction of flow of electrons. So my current will flow like this, from positive to negative in a direction opposite to the direction of flow of electrons. Now, all of us know that when we take two water bodies, okay, water always flows from high potential to low potential. So, if there is water in the dam, it will flow from top to bottom. So, water always flows from high potential to low potential, or we can say in simple words, from high level to low level. Okay. In the same way, positive is always at a high potential and negative is at low potential. So, your current always flows from high potential to low potential. So you should always remember the flow of electrons is this way, then the flow of current will be opposite to the flow of electrons. So here you can see the electrons are just moving, but after it was switched on, the electrons are drifting at this side only. Now when electrons are drifting at this side, you can see the change in current in the ammeter. Now when it is off, that is no current is flowing, the ammeter reading also shows 0. So what is current? Current is the rate of flow of electric charges, and here which charges are moving? The electrons are moving, that is the negative charge is moving. So we can say that current is charge upon time. So whenever we say rate, it is per unit time. So current is the rate of what? Rate of flow of electric charges. So I is current. So current is, Q is the total charge that is flowing, and T is time in seconds. Now charge, the unit of charge is always coulomb, unit of time is seconds, and unit of current is ampere. Ampere. Okay. So current is the rate of flow of electric charges. So if I take the units, the unit of current is ampere, the unit of charge is coulomb, and the unit of time is seconds. Okay. So when it will be 1 ampere, when both of them will be 1 and 1. So what do we say? A current of 1 ampere means there is 1 coulomb of charge passing through a cross section of a wire every 1 second. So if 1 coulomb of charge is passing through a cross section of a wire in 1 second, then the current is said to be 1 ampere. So SI unit of current is ampere, its symbol is A, and when it will be 1 ampere, when 1 coulomb of charge will flow through a cross section of wire in 1 second. So students, if I say current is charge, total charge upon time, okay, and what is total charge? Okay, the charge is carried by electrons, so the total charge will be the charge on one electron into the number of electrons that are flowing through a cross section in 1 second. So Q can be written as N, that is the number of electrons, into E, where this E is equal to charge on one electron upon time. Okay, so you can rewrite the formula as I equal to N into charge on one electron upon time. We know what is charge on one electron. It is 1.6 into 10 raised to power minus 19 coulomb, and this charge is in negative. Okay, so this is the charge on one electron, minus 1.6 into 10 raised to power minus 19 coulomb upon time. So we can use this knowledge also in our numericals. Also, if I is equal to Q upon T, then we can say that your Q, that is the total charge, will be I into T. So this formula and this formula will be used in doing the calculations of this chapter. So let's go ahead and see some sums. A charge of 12 coulomb passes through the filament of a car headlamp bulb in 4 seconds. So they have given total charge and they have given time. What is the current? So we know current is charge upon time. So charge was 12 and time was 4 seconds. So 12 upon 4, which is 3 ampere. You have to make sure that you remember the units very well. So they have asked current, so the answer will be in amperes. Let's see the next question. A current of 0.5 ampere flows for 20 seconds through a small electric motor. How much charge has passed? So they are asking total charge. They have given current and time. So we know charge is current into time. So it will be 0.5 into 20, which is 10 coulombs. Let's see another question. A current of 200 milliampere flows for 2 minutes. How much charge has passed? So again, charge we know is current into time, but here if you see the units, this is in milliampere and this is in minutes. We have to convert it into ampere and we have to convert minutes into second. Now this is a very easy conversion. So we will directly write charge is equal to current into time. So here you can see 200 milliampere we have converted into ampere by dividing it with 1000. So it becomes 0.200. And for 2 minutes we have converted into seconds by multiplying it with 60. So it becomes 120 seconds. So the answer comes out to be 24 coulombs. Now, what is the total number of electrons constituting 1 coulomb of charge? And the answer is also given. So let's see how to arrive at this answer. Now we know that this total charge is equal to N, that is number of electrons, into E, where E is charge on one electron. Now they are asking if this is 1 coulomb. if this is 1 coulomb, the total charge is 1 coulomb, what is the number of electrons? So they are asking this n. And we already know the charge on one electron is minus 1.6 into 10 raised to power minus 19 coulomb. Now this minus shows only that it is a negative charge. So now for finding n, what we will do? N is equal to 1 upon this, 1 divided by this. So 1 divided by 1.6 into 10 raised to power minus 19. So what we will do? 1 upon 1.6 into 10 raised to power 19. So the answer comes out to be 6.65 into 10 raised to power 18. So these many electrons constitute 1 coulomb of charge. Now let's talk about what are electric circuits. So electric circuit is defined as a closed loop through which the electrons flow. So here you can see a simple electric circuit. Here there is a battery which is the source of chemical energy. Here there is a load, that is a bulb, and there is a switch. So if this is positive and negative of a battery, the current flows from high potential to low. So positive to negative. So current will flow in this direction and the bulb will glow. So this is a simple diagram to show electric circuit. So this is a closed path. So electrons are moving in this closed path, you can see. Okay. So electric circuit is defined as the closed loop or closed path through which the electrons flow. So now what is a circuit diagram? We saw that this was an electric circuit. So now we have to represent it in the form of diagrams. So circuit diagram shows how components are connected together. Now this is just a closed loop through which the current flows, and a circuit diagram, the diagram of the circuit will show how the components are connected together. So a circuit diagram is a graphical representation of an electric circuit. So it represents the electric circuit. Now the schematic diagram shows the components and interconnections of the circuit using standardized symbolic representations. So here you can see a schematic circuit diagram. Here we have taken the symbol of switch. We have not drawn the switch. We have taken the symbol of battery and we have not actually drawn the battery. And this is the symbol of light bulb and we have not drawn the bulb. And this is the representation of a wire and we have to show the direction of current also. So this is a schematic circuit diagram. Now there is also a pictorial circuit diagram which we saw earlier. It uses simple images of components. So it uses simple images of components, whereas the schematic circuit diagram uses the symbols. Now let's talk about some common components of these circuit diagrams. First component is cell or a battery. So cell is necessary. Why? To push the electrons around a complete circuit. So without cell, none of the circuit is complete. So the first and the most important component of the circuit is a cell, and it is necessary to push the electrons around a complete circuit. So here you can see I have given a real picture of the cell, and here this is a symbol of the cell. Okay. Now a cell is symbolized by two lines. So the longer line represents positive side and the smaller line represents the negative side. Okay. And this is connected through a circuit with a lamp. Okay. So current will flow from positive to negative and the lamp will glow. Now, what is a battery? A battery consists of two or more cells. The major difference between a cell and a battery is here in the representation you can see cell is represented by two lines like this. Whereas if we say what is battery? Battery is two or more cells connected together in series. So if this is one cell, it is connected to another cell, connected to another cell and so on. So it can be connected to two or more cells. So that is a battery. Okay. So in both the cases the current flows from positive to negative, and here obviously you can see here the current is less and here the current is more. Now let's have a detailed distinction between a cell and a battery. So the difference between cell and battery is that a cell is single unit that converts chemical energy into electrical energy. So this is very important. What is the use of cell? It converts chemical energy which is stored in the cell into the electrical energy. And what is battery? It is a collection of cells. So two or more than two cells is called a battery. So cell and battery both store the chemical energy and then converts the stored chemical energy into an electrical energy. We have already seen the circuit diagrams of cell and battery. So let's go ahead and see some more difference of cells and battery. The basic difference here, we know already the definitions. It is a single unit and it is a collection of cells. Okay. Now, these are the different types of cells: dry cell, wet cell, reserve cell and fuel cell. And batteries are primary battery and secondary batteries. Secondary batteries are the ones that can be charged again. Now, these are always light and compact and they are heavy. You must have seen the batteries of your cars. They are so heavy. Now, power. They supply power for a short time, okay, because it is very small, and they supply power for a long time. The applications are clocks, lamp, radio, remote control devices, etc. And here there are major applications in automobiles, inverter, emergency lights, etc. We use batteries. Now, obviously this is cheap and this is costly. So now that we know the basic difference between cell and battery, let's move on to the next component. So the next component, which is also very essential, is a switch. What is the use of switch? The circuits can be opened or closed by using a switch. Now here you can see an open circuit. See, you can see there is an obstruction to the flow of current. So if current starts flowing like this, okay, if this is the bulb, current starts flowing. Now the path is obstructed. The current can't move. Okay, so we say that it is off and we refer to as open circuit. Since it is open, it is off. Okay, the bulb doesn't glow. Now here the current flows, okay, and this is a closed circuit, so it is in on position. Now current can flow like this and this bulb will glow. Now here are different types of switches that we use in electrical components. The most common types are these type of switches that we come across, and these type of switches are there in your video games and all. So this is the diagram or the symbol of open circuit and closed circuit. Now there is also one more symbol of switches. These are basically called keys. So here, if in this position, if there is a dot, it means current can pass through and you can see the bulb glowing, okay, because the path is complete. You have put the key inside. Here the key is not there, so it is an open circuit and the bulb is not glowing. So at times, instead of switches, you can be given symbols like this for keys. So by seeing this, you should know that in this case, when there is a dot, the current flows. That is, it is a closed circuit, closed path for the electrons to move, and this is an open path because here the electrons can't move. Now going further, for our next component, it is indicator. It is shown by this symbol. So indicator is indicators such as bulb. So most of the time the indicator will be bulb. It is designed to emit light as a signal when a current passes through it. So here when you can see, okay, since the current is passing, so the bulb is glowing, and here the current is not passing, so the bulb is not glowing. So from here we know that this is an indicator that the current is following a closed path. Okay. So most of the times we don't draw bulbs like this, we draw symbol like this. So this is a symbol of bulb that we use. This is also called an indicator because it indicates that the current is flowing by emitting light. Moving on to our next component, that is ammeter. Now here you can see these are the two pictures of ammeter that I have given you, and here you can see the reading is in amperes. So we know that current is measured in amperes. So ammeter is an instrument which measures the current that is flowing in a circuit. So here you can see a circuit. This is the source, that is the cell or a battery from which current is flowing, and it is going in the load. Now load can be anything like your bulb, fan, anything, and hence the current is flowing in this direction. And here we have attached the ammeter in series, and that is why it is recording the current that is flowing in the circuit, and it is noting down the current in amperes. So what is an ammeter? Ammeter is a device which measures the current that is flowing in this circuit, and it is always attached in series. Now the next component is voltmeter. Here I have given you the picture of voltmeter, and here you can see the reading is in volts. So voltmeter measures the potential difference across the two ends, or we can say it measures the voltage. So if this is a circuit and this is the battery, then the current is flowing from positive to negative. So it is flowing like this. So across the ends of the load or of the bulb, we have to measure the potential difference, because we know current will flow from high potential to low potential. So what is the potential at this point and what is the potential at this point? So for current to flow, there has to be a potential difference. So we want to measure here and here. So how can we measure? By attaching the voltmeter in parallel. So you should always remember that voltmeter is attached in parallel because it wants to measure the potential across the ends of a device, and that can be done only by attaching it in parallel. So what is the use of voltmeter? It measures the potential difference applied across the ends. So here you can see a circuit diagram. Now this is the cell, positive and negative. So the current will flow from positive to negative in this direction. So this is the flow of current like this. So this is the circuit. Now you can see this ammeter is connected in series. Okay, because it is measuring what? It is measuring current. So current is always measured by putting your ammeter anywhere in the series. And we have to measure the voltage across this load. So we have to take 2 points and attach our voltmeter in parallel. So let's move ahead and study about another property, that is resistance. We studied what is current. Now let us talk about what is resistance. So here you can see Mr. Volt trying to push hard so that the electrons can move and current can flow. But here there is something which is restricting the flow. So if you see here in the other diagram, the voltage is pushing the electrons to move, okay, but there is something which is obstructing the flow of these electrons, and hence you can see a small amount of current passing. So this obstruction to the flow of electrons and hence the obstruction to the flow of current is known as resistance. And how we can introduce resistance in a circuit? By using resistors. So these are the different resistors. Here you can see there are different colored bands on the resistors. So these color bands tell you what is the measure of the resistance. So for example, this is 2 ohm resistor, or this is 5 ohm resistor, or this is 1 ohm resistor. So you can read the bands and come to know that what is the resistance. So they provide a fixed resistance. Okay. So they provide a fixed obstruction to the flow of current. So here you can see when two resistors are attached in series, that is one after the other, and here they are attached in parallel, that is across these two ends, two resistors are attached. This is the symbol of resistance that we use nowadays, but the most common used symbol is this, which we have been using till now. But for your portion in your circuit diagrams, if you see a symbol like this means that this is a resistor. So remember both the symbols of resistors. Here you can see a complete circuit diagram. Here the resistors are attached in series, and here you can see it is attached across the 2 points. Across the 2 points. Okay. So since it is across, these two are in parallel. We'll talk about the connections of resistors in series and parallel in the coming video lectures, and we'll also learn how to calculate the total resistance of a circuit if the resistors are connected in series or in parallel. So there we will study about them in detail. Right now you should know that what are resistors. They offer obstruction to the flow of current and they give fixed resistances. Now there's something known as variable resistors also. In the earlier diagram we saw that these all are fixed resistors. They give a resistance of say 2 ohm or 5 ohm, whatever it is. But here you can change the resistance in the circuit. So it is somewhat like this. You keep on changing the position of this jockey and you can vary the amount of resistance that this resistor is offering. So these two are the two symbols of variable resistors. We had seen earlier that only this green portion, this was resistor, the green portion. Now there is a line here, a slant line with an arrow. This shows that this resistance can be varied or changed. So here you can see a circuit. If this is the power supply or a battery, okay, then this is positive and negative. So current will flow like this in the circuit, like this. You can see an indicator or a bulb here and an ammeter here, and also a voltmeter is attached in parallel to the bulb. So suppose now this is not there. When current is flowing, okay, in this circuit the bulb will glow and there will be some reading in the ammeter showing how much current is flowing and some reading in the voltage showing how much power supply is there. Okay. Now if we use this variable resistor, okay, what will happen? We will keep on changing the resistance. Okay, so we'll keep on moving this and we will keep on changing the resistance. If we increase the resistance, means we are obstructing the flow of electrons, then very less current will pass and then the bulb will become dim. And if we decrease the resistance, that is we are offering less obstruction, then more current will go. Okay, so more current will be able to pass through, then the bulb will glow brightly. So this is the use of variable resistor to change, to allow the current to be varied. So when you change the resistor, you will also note a change in the ammeter reading and a corresponding change in the voltmeter reading too. So now let's talk about diodes. It is also a very important component. Now a diode allows current through in one direction only. So you see diodes look somewhat like this and this is the schematic symbol of it. Other than this, we can also put a circle here. So that is also a symbol. Now here a very important thing to note is this is the direction of normal diode current flow. So if the diode is like this, okay, then positive has to be there and negative has to be there. The current has to be in this direction only to allow the passage of current. Now suppose this is the diode and current is coming from this direction, then it will not allow the current to pass through. So here you can see that this is positive and this is negative, and diode is also attached like this, so positive and negative. So current is coming and it is allowing the current to pass through, and that is why this bulb is glowing. Whereas here if you see, this is negative, so current will flow like this, So if current is coming like this, it will not allow current to pass through it. That is why this bulb will not glow. So how is it useful? If by any chance, if by mistake, we put the battery in the other way, in other words, if we change the polarity or put the battery in the wrong position, then what may happen? Our appliances which are attached in the circuit may get damaged. Okay. For example, the radio gets very easily damaged if the connection of battery is in the wrong direction. So there, if a diode is present, then even if you have changed the battery's position, then the current will not flow, okay, because the diode will not allow the current to pass through if it is in a wrong direction, because it allows current to flow only in one direction. So now since the current will not flow, your radio will be saved. So this is how diode is used. So it allows current through in only one direction. So this is also very helpful. Now let's look at another component, LED. Now, LED is light emitting diode. It emits light when a current passes through it. So it is simply like an indicator, a bulb, but it uses a very less amount of current. That is why it is very useful as an indicator. Here you can see these are the different colored LEDs that are available in the market. You all must have used for your different projects. These are the two symbols. Okay, you can make a circle or leave it. So both are correct symbols. So here I have used an LED in my circuit. So here you can see this is the battery, positive and negative. So the current will flow like this. So in this direction the current will flow in the circuit and the LED will glow to show that the current is flowing in the circuit. So LED is a very good indicator to show when current is passing through the circuit or not. Next component is heater. So heater is designed to transfer the energy from an electric current to heat the surroundings. So whenever we want to heat something, okay, what we will do, we'll employ a heater in the circuit so that all the current converts into heat. Okay, so heater is designed to transfer energy from an electric current to heat the surroundings. So it uses the electric current and convert it into heat. So this is the symbol of a heater. The other symbols that are often used is this also, but nowadays we use this symbol. You can see I have used 1, 2 and 3 heater in the circuit. What is heater? It is used to transfer the energy from an electric current to heat the surroundings. Now, a very important component, that is fuse. These are the different symbols of fuse. This is the old version, old symbol of fuse. Okay, this is the new symbol of fuse. But these symbols of fuse are also used in many of the circuit diagrams. For us, we will use this symbol of fuse. Now, what is a fuse? Now, students, fuse is made up of a wire. Okay. Now, this wire is an alloy of the type that it has a very low melting point. That is, it melts at a low temperature, at a particular temperature that we want. Now, when it melts, it breaks, it stops the flow of current in the circuit. Now, why is it important? Now, suppose by accident there is a large flow of current in the circuit. By accident, a large voltage is applied and a large amount of current flows in the circuit. Now, in the circuit of your house, in the household circuit, there are many important appliances that are attached. Now, if this high current flows in those appliances, it may damage the appliances. Okay? Because the appliances are made to operate on a certain current and voltage. Okay? There are certain ratings that are written on those appliances and they run only on that particular amount of current and voltage. But here, if by accident more amount of current flows, then it may damage all the appliances. Now, to safeguard our appliances, we use fuse. So what happens here in the circuit, you can understand that if by chance a large amount of current flows, okay, so here if the current is flowing, this material which was there, now suppose this was the wire which was there inside, this wire gets heated up very fast. Now this wire also has a property that it has a high resistance. So it is offering resistance to the flow of current. Now if more amount of current is there, more resistance is there, because of more resistance, heat is generated. And this heat melts this wire. Now if this wire melts, the wire breaks and now the high current cannot flow. And if the current cannot flow, our appliances are saved. I'll repeat again. The fuse wire is made up of an alloy of such a material that it has a high resistance and a low melting point. So it is offering more resistance to the flow of current. Now, if current is high, okay, higher than the expected, then the resistance offered will be more. If resistance is more, there will be heat generated, and because of the heat and the fact that this wire is made up of a low melting point material, then this wire will melt and break down. Okay, once it breaks, it disconnects the circuit is broken, or we can say the circuit is open. Now the current can't flow in the circuit and hence our appliances are saved. So fuse is a very important component. So this was all about electric current, charges and different components in an electric circuit. I hope you enjoyed learning these topics with me. If you have liked the video, please give it a thumbs up and write in the comment box. And also, if you have not yet subscribed to my channel, do it right away and don't forget to tap on the bell icon because we'll be uploading all the videos of physics and chemistry of GCSE curriculum. Also, please share our channel with all your friends and keep the learning on. Thank you and have a nice day.